Assalamu alaikum. I am Tofikur Rahman. Today I will discuss about wireless power transfer system for electric vehicles. So electric vehicles represent a vital role day by day. For a green Bangladesh, electric vehicles plays a great role nowadays. By embracing electric vehicle, we can not only mitigate the impacts of climate but also create a better world for future generation. So let's begin the presentation. Today in the presentation, my group members are Tanvir Rahman, Mehrab Islam Omi, Hussein Sarwar, and Shoaib Ahmed. So in this slide, I would like to discuss about the introduction part. So mainly I would like to discuss about the importance of electric vehicles in this slide. So as the world seeks solution to mitigate climate change and reduce pollution, the transition to electric transportation has become increasingly high. So in this presentation, I will explore the environmental, economical and social benefits of electric vehicles and their role in achieving sustainability goals. So let's dive into the transformative information of electric vehicles and their significant shaping and more sustainable future. So at first we have to know what is electric vehicle. So electric vehicle are that vehicle that are powered by electric motors rather than traditional internal combustion engine fueled by gasoline or diesel. These vehicles use electricity stored in batteries to generate power, which is then used to propel the vehicle. Electric vehicles come in various forms, including battery electric vehicles, plug-in hybrid electric vehicles, and hybrid electric vehicles, and many more. So, in this slide, I would like to describe about our objectives for this presentation. At first, environmental benefits. Environmental benefits are very important in our presentation because highlight the environmental benefit of electric vehicles, including reduced greenhouse gas emission, improved air quality, and mitigation of climate change. Second is economic advantage. Explore the potential environmental impacts of widespread EV adoption and the role of EVs promoting sustainability, and many more. Third one is insights into adoption. Uh, uh, Insights into adoption mean that economic advantage mainly analyzing the economic advantage of EV adoption, such as cost saving for consumers, job creation in the clean energy sector, and opportunities for innovation and economic growth. Evaluate the long-term economic benefits of transition electric transportation, including reduced dependence and fossil fuels and enhanced energy security. And third one is explore economic advantage. Explore the economic advantage of EV adoption from a global perspective, considering factors such as energy savings, reduced healthcare costs, and increased competitiveness in the automobile industry. Then discuss the potential economic implementation of EV adoption for various stakeholders, including manufacturers, policymakers, and consumers as well as. So identify opportunities for a collaboration and investment also. Electric vehicles plays a vital role. So in this slide, I would like to describe about the theory of electric vehicle. So wireless power transfer for electric vehicles is transmission of electric power from the power source to an electrical load without the use of physical connectors or any kind of power. History of WPT began with the formulation of Maxwell's equation in 1862. Maxwell described a phenomena of radio to wireless power transformation for electric vehicle waves in his equations. Later, in 1884, Henry Poynting illustrated electromagnetic waves as an electric energy flow and is used in his polynomial theorem. Then Nikola Tesla investigated the principle of WPT, and the end of the 19th century, Tesla's experiment was not exploited. to a commercial level because of its seemingly unsafe nature. Low efficiency and financial constraints also is a reason. After Tesla's initial experiments, electromagnetic waves are used for wireless communication and remote sensing application. From here, my group member Tanvir Rahman will continue the presentation. I hope you enjoy his presentation as well. Thank you.
Thank you, Tofikur Rahman. Now, I will brief my slide. At first, I have to say, what is methodology? A methodology refers to a system of method, principle, and the rules used to guide a specific process or study. It encompasses the theoretical analysis of a method and the principle associated with a particular field, ensuring a structured approach to achieve desired outcome. And now I would like to say about the methodology in wireless power transfer system for electrical vehicle. The methodology for designing a wireless power transfer system for electrical vehicle where using MATLAB Simulink involves several key steps. At first, mathematical models of wireless power transfer system components are developed, including a transmitter and receiver, coils, resonant capacitor, and power converter. These models are translated to Simulink blocks. Next, the Simulink environment is a configured for simulation with appropriate solver settings and parameters chosen. Components are integrated into the Simulink model according to system topology and circuit diagram. And the control algorithm are designed to regulate power flow and maintain resonance, and the simulation experiments are conducted to evaluate system performance, analyzing metrics such as efficiency, electromagnetic interference optimization is performed. To improve system parameters and control strategies, the Simulink model is validated against theoretical calculation of real-world data. Finally, the simulation results are interpreted to assess the feasibility and the effectiveness of the design wireless power system for electrical vehicle. Next slide. Social and economic impact of widespread adoption of the wireless charging. Number one, improved convenience and user experience. Wireless charging for electrical vehicle eliminates the needs for flagging in the making charging process more convenient. This can increase the adoption rate of electrical vehicle as the hassle of the dealing with cable is removed, enhancing the overall user experience. Increased adoption and electrical vehicle. The convenience and easy cases of users associated with wireless charging can lead to higher adoption rate for electrical vehicle. This can be contribute a reduction in the reliance on the fossil fuel, helping to the mitigate climate change and the reduce air pollution. Economical growth in the technology and infrastructure sectors. The widespread adoption of wireless charging will spur growth in sector related to technology development, manufacturing, and infrastructure deployments. Companies involved in the production of wireless charging technology, as well as those building the necessary infrastructure, will experience economic benefits. And the job creation and skill developments. The new job will be created in the manufacturing, installation, and maintenance of wireless charging system. Additionally, there will be a need for training program for equipment worker with the skill required to support this new technology. The reduction in greenhouse gases emission. As the adoption of electrical vehicle increases due to the convenience of wireless charging, there will be a corresponding decreases in the greenhouse gases. Emission from the traditional internal combustion engine vehicle. This contribute positively to environmental sustainability effort. Next slide. Now, I will explain circuit diagram. That is our project. There is a lots of equipments on the circuit diagram. Number one is AC power. This is the incoming AC power source, which can be single phase or three phase power, AC and DC with PFC. This block convert the AC power from the grid to DC power. Power factor correction improves the efficiency of the conversion by minimizing reactive power. The primary frequency compensation. This compensates for the fluctuation in the AC frequency from the power source. And secondary frequency compensation. This compensates for the fluctuation in the AC frequency at the receiving coil, transmitting coil. This coil that transfers the electrical energy to the receiving coil via magnetic resonance. And the receiving coil. This coil receives the electrical energy from the transmitting coil and convert it back to AC circuit. DC to high frequency AC. This block convert the DC output from the receiving coil back to AC currents and at a higher frequency. Battery. The battery stores the electrical energy from wireless power transfer system. A wireless power transfer system allows the contact rate charging electrical vehicle. The AC power from the grid is converted to DC power, then to high frequency AC current. This current transmitted wirelessly to receiving coil in the vehicle via magnetic resonance. The receiving coil converts the current back to DC power, which is stored in the battery. Electrical vehicle typically use a 12-volt battery to power low voltage electronics and a high voltage battery pack around 400 voltage to more power electrical motor. The high voltage battery pack use a battery management system to monitor and control individual battery cells, and a DC-DC converter step down the voltage to 12 system. This is all about my presentation. Now I would like to invite our next group member to brief a slide. Thank you.
Hello everyone, I'm Islam Ami. Today I'm gonna explain the simulation part of the presentation. So let me start. At first we have a continuous power system where we can produce more power from here to the entire system. At first we can see that a source rectifier is connected with AC source, which also is connected with a current measurement. So it's connected to the source rectifier, which gradually goes to the DC power and go to magnetic resonance system, which is connected to HF inverter. HF inverter is connected to mutual inductance is also connected between this coil, which is important to generate power. So this power gradually goes to the vehicle rectifier, which is connected with a lithium ion battery, which is responsible to convert the current from AC to DC. First we see that the lithium-ion battery is connected with the voltage, bat scope, bat input power, and SOC. These are important to measure our power and the required power that's needed to mm, measure the power. Here we can see the input reactive power and input active power is connected with source and source current here, which is also connected with the bat scope, which measures this power. We can see here a DC link current, and VDC link current is also connected to a scope, DC link, and also DC link power. So these are responsible to the entire system of a wireless electronic vehicle charging systems. Thank you everyone. Let's move to the next slide. So main part of the simulations are elaborated here. Like we can see the simulation of rectifier here. Like rectifiers are made of like four diodes here, which are connected to terminal 2 and type of here D3 and D4, and D1 and D2 are connected together to the number 3 of port, and C2F is parallelly connected with the diodes here and the number 4 pin is connected to D2 and D4. Now next move to the next slide. The simulation of inverter is also done there. It's just the entire system which is implicated on the main simulation. Like we can see HF and H2 and H3 and H4 VGT here, like is connected with a PWM DC to DC converter. It also is connected to NOT gate, and which is necessary. Point 1 and 2 is connected to H1 and H2, which are also parallelly connected with point 3, and point H3 and H4 is connected with point number 4, which is also connected to P and junction. So next, move to the next. So here we can see the specification of source rectifier, like it's done with a universal bridge mask link, which we got from the MATLAB. So the block implement of bridge selected power electronics device series, it's a super circuit connected parallel which each switch device and press. So the number of bridges is done is 2. So the snowbird source rectifier we can see here exponential to the 5, and power electronics device and allowance ohms is done here 1 to the power exponential minus 3. Thank you. Now in the next stage we'll explain the mutual inductance of the circuit, which is also a main component of the circuit. You can see the mutual inductance here. Mutual drop parameters of mutual inductance is the specification of mutual inductance is done. The number winding monosample impedance is 1 to the exponential power minus 3 to the 26. 1 mass is when exponential 1/26 in winding 2 of self impedance is in ohm is done here exponential minus 3 and to the power 56.79 exponential minus 6, and mutual impedance of RM ohm is also done here. So next we let's also lithium ion battery is connected on the simulation. So let's explain the lithium ion battery here. Lithium ion battery is normal voltage was given 360, rated capacity is 100, and the initial state of the charge is 50%. Battery response time is 5 seconds, 10 seconds. So this includes the important part of the simulation. Here we can see the wireless energy transmission methods. It's like an entire system described here. Like at first we can see the primary set winding, which power supply and power electronics rectifier inverter here, which is done for compensation topology transmission coil, which receives through the transmission coil, and receiver coil is connected together, which is also connected to a compensation topology, and then the secondary side it transfers power electronics rectifier and buck converter, which is connected to a battery. This is the entire process. How can we get the transmitted power through transmission and receiver coils? So let's explain these methods, like the inductive coupling. Inductive coupling is one of the most common methods of the wireless energy transfer based on the principle of electromagnetic induction. It involves two coils, a transmitter coil connected to power source and a receiver coil connected to the load. When an alternating current flows through the transmitter coil, it induces a voltage in the receiver coil, transferring power wirelessly. The resonant inductive coupling. Resonant inductive coupling improves the efficiency and extends the range of wireless energy transferring by utilizing resonance phenomena. By matching the resonance frequencies of the transmitter and receiver coil, energy transfer can occur over longer distances with minimal energy loss. It requires a microwave transmitter and to generate high frequency electromagnetic waves and rectifying antenna at the receiver to convert the waves back to the usable electrical energy. Radio frequency energy harvesting. Radio frequency harvesting captures ambient radio frequency signals from sources such as Wi-Fi, routers, cellular networks, and radio towers to generate electrical power. Ultrasound power transfer involves the transmission of acoustic waves in ultrasonic frequency range, typically in kilohertz, to transfer energy wirelessly. It's suitable for applications requiring precisely energy delivery, such as medical implants and underwater devices. Thank you. Now let's move to the next slide. So this is basically the results we got from the simulations. At first, we can see the battery voltage and battery current. You can see here the ampere and voltage here. When the ampere reaches 10 to 15 volts, it's got static. It's moved to 4 at a static rate after receiving there. Same goes here for the battery voltage at 400 voltage. It reaches at 0.4 time. So this is the necessary winding that's required. So let's move the roadside winding voltage and roadside winding current. So roadside winding voltage and roadside winding current, these graphs are unlikely related to the electric vehicles. Electric vehicles are electric motors and batteries and wouldn't have winding and voltage terminology used in levels suggested in the graph. So it is important for the electric generation in the distribution system. Winding can refer to the coil of wire in a transformer or generation, and roadside could refer to a roadside power distribution transformer. So this is also the necessary graph we got for roadside winding voltage and roadside winding currents. Thank you.
Thank you, Omi. Now I discuss about the analysis. First of all, cost analysis. Estimate the cost associated with implementing wireless energy transfer system, including equipment installation, maintenance, and operation expense. Simulation slide. Use computer simulation to model and analyze the performance of wireless energy transfer method under various conditions and sensors. Case studies examine real-world case studies and example of successful implementation of the wireless energy transfer method in different applications. Consult with industry expert, research, and stakeholder to better inspire and perspectives on the practical and feasible of adaptive energy transfer method. Consider safety. Evaluate the safety implication of wireless energy transfer method, including electromagnetic radiation, exposure, and interference with electronic devices. Now I discuss about the limitation. Efficiency concern. WPT system typically have lower efficiency compared to traditional wire changing method. Energy losses occur during power transmission due to factors such as electromagnetic interference, coupling interference, and resistance in the transmitter and receiver coil. Number two, limited range. The effective range of the WPT system is typically limited to a few meters. This restricts the flexibility of EV charging, especially in public places where element between the transmitter and receiver coil is required for installing power transfer. Number three, element sensitivity. Proper element between the transmitter and receiver coil is for power transfer can significantly reduce charging efficiency and may require additional matching such a element guide or automated posting system to ensure optimal performance. Number four, implement an environment factor. Environmental factors such as weather condition, electromagnetic interference from nearby electronic devices, and metallic object in the vicinity and affect the performance of WPT system. Shielding and filtering machines may be necessary to maximize the effect. Cost and complementary. The implementation of WPT system involves the use of specialized components such as transmitter and receiver coil, resonant capacitance, and power electronics. These components can be expensive and the overall system design may be complex, requiring careful and improvements and testing. Now I discuss about the recommendation for future research. Efficiency optimization. Investigating the method to further enhance the efficiency of wireless energy transfer such as improving coil design, optimizing resonance and frequency matching, and reducing energy losses during transmission. Safety studies conduct comprehensive studies to assess the long-term health and safety implication of being exposed to electromagnetic field. The EMF generated by wireless charging system addressing concern and informing regulatory framework. Integration with renewable energy integrated the renewable of wireless energy transport system with renewable energy sources such as solar, wind power to enable sustainable and grid-independent charging solution. Environmental impact assessment. Evaluate the environmental impact of wireless charging system through their life cycle, including raw material extraction, manufacturing operation, and end-of-life disposal of identify opportunity to reduce environment footprint and promoting sustainability. Economical analysis. Conduct comprehensive economical analysis including cost benefit assessment, return to environment ROI calculation, and total cost of ownership TCO evaluation to assess the financial viability and economical impact of deploying wireless charging instrument. Thank you. This is my part. Now I request to slide.
Hello sir, Assalamu alaikum. I am Shahid Ahmed from Technology Department. Now I present my electric vehicle safety considerations in wireless technology transfer. In electromagnetic radiation exposure, this is overcurrent and overvoltage protection, its user education and training, environmental impact assessment, and electromagnetic radiation exposure is to evaluate the potential health risks associated the exposure to EMF generated by wireless energy transfer systems. The conduct studies the access of EMF levels and determine safety exposure, its limits, humans and the environments. And the overcurrent and the overvoltage protection is the incorporated the overcurrent protection and the overvoltage protection. It is the mechanism into wireless charging systems to safeguard against electrical faults, short circuit, and voltage surges. Implement the fail-safe and features to automatically disconnect power in case of abnormal conditions. And thirdly, the user education and training. This is the provide the comprehensive user educations and training in programs to raise the awareness to safety consideration related to wireless energy transfer. It educated user to proper handling the installation and maintenance procedures to minimize the risks, prevent and accidents. Fourthly, the environmental impact assessment. It's a conduct environmental impact assessment to evaluate the potential ecological and health effects of wireless charging infrastructure of wildlife ecosystems and public health. Implement measures to mitigate environmental risk and promote sustainability practice. And finally, I finished my conclusions. And the widespread adoption of wireless charging technology is promised to transform our interaction with electronic device, vehicles, and infrastructure, offering significant social and economical benefits. It has also environmental benefit. It enhances the environment and drives economic growth. It's through infrastructure and investment and job creations and promotes sustainability by improving energy efficiency. It's ensuring equability access and addressing regularity and educational needs are crucial. It's embarrassing the technology can shape more conduct sustainability and is prosperous futures and advancing, innovating and inclusive growth. The infrastructure and on this technology we can unlock its numerical and social economic and environmental benefits that contribute and more and sustainability equity future. The wireless charging offers unparalleled conveyance and accessibility. Is simplifying the charging process and enhancing productivity of user across the diverse settings. The technology fosters infrastructure investment, job creation and economic growth as stimulating. It's stimulating and innovating in the renewable energy more technology sectors. Moreover, wireless charging promotes the energy efficiency, environmental sustainability, and the marketing expansions. As we as we embrace wireless charging technology, it is essential to consider its social and economic impacts, including equity, inclusions, and consumer adoption. By addressing regulatory frameworks, public awareness, and education, we can ensure safe, reliable, equitable access to wireless charging infrastructure for all. And harnessing the potential of wireless charging, we can accelerate progress towards achieving our collective goals and innovation, sustainability, and inclusive growth. Thank you. It's all over our presentation. Thank you, sir, for listening me.